Good morning, dear students. I welcome you for the chemistry class. Today in this video, I'll be discussing about the effects of oxidation, that is corrosion and rancidity, and about alloys. The effects of oxidation reactions in everyday life. The gradual eating up of metals by the action of air, moisture, or by using any sort of chemicals like acids on their surface is called corrosion. The most commonly seen example of corrosion of metal is rusting of iron, that is, a formation of brown flaky substance on the iron objects on exposure to moist air. So, rusting. Iron, when reacts with oxygen and moisture, forms a brown flaky substance, a red substance which is called rust. So, rust is hydrated ferric oxide. So, iron reacts with oxygen and moisture. So, these two are the necessary conditions for the iron to rust. So, there's a formation of hydrated ferric oxide. The rusting of iron is a redox reaction. Corrosion or rusting weakens the iron and steel objects and structures such as railings, car bodies, bridges, ships, which cut down their lifespan. Prevention of rusting. So, how do you prevent rusting? So, for rusting to happen, iron must come in contact with oxygen and moisture. So, rusting is prevented where the reaction has to be prevented between the atmospheric moisture as well as with the iron article. So, how it is done? There are few methods. The first one is painting. So, painting keeps out the air and moisture. Greasing. So, it forms a barrier layer. Again, it keeps out the air and moisture. Galvanization. It's a coating of molten zinc on iron articles. So, zinc forms a protective layer and prevents corrosion. Electroplating. It's a method of coating one metal with the another by the use of electric current. So, this method is not only leads to production but also enhances the metallic appearance, like nickel plating or silver plating. Another method is alloying. Next is corrosion of copper. So copper objects lose their luster and their shines after some time. So they lose their lustrous property because the surface of these objects they do acquire a green coating which is a formation of basic copper carbonate. So when it is exposed to air, the conditions are the copper reacts with oxygen as well as water, then moisture and carbon dioxide. So there's a formation of basic copper carbonate which is green in color. Coming to corrosion of silver metal. The surface of silver metal gets tarnished or becomes dull on exposure to air due to the formation of coating of black color silver sulfide Ag2S on the surface by the action of H2S which is present in the air. So Ag plus H2S forward reaction. So what we get is the black color silver sulfide with the elimination liberation of hydrogen gas. Rancidity. The taste and odor of the food particles, the materials containing fat and oil, changes when they are left exposed to air for a long time. This is called rancidity. So, it is caused due to oxidation of fat and oil which is present in the food particles. Methods to prevent rancidity by adding antioxidants like butylated hydroxyanisole or butylated hydroxytoluene. Vacuum packing, replacing air by nitrogen. So, nitrogen is an inert gas. Refrigeration of foodstuff or keeping it away from light. Coming to alloy. Alloy is a homogeneous mixture of two or more metals, or a metal with a non-metal is called alloy. For example, manganese steel. So, they do have iron, manganese, carbon, and nickel steel, for example. So, nickel steel, they do have iron and nickel. Brass, it's an alloy of copper and zinc. Bronze is an alloy of copper and tin. Sodium amalgam. When we say amalgam, amalgam in a sense mercury should be there. So sodium amalgam, so sodium and mercury. Zinc amalgam, so zinc and mercury. So how these alloys are prepared? So one particular metal will be melted and that will be fused to the other metal. So both the metals will be melted and they'll be fused based on the different composition. So percentage do vary and that's how alloy will be prepared. Properties of alloy. So alloys are stronger than a metal from which they are obtained. It is harder than its constituent metals, and they are more resistant to corrosion. The melting point of an alloy is lower than its constituent metal. For example, solder. Solder, it's an alloy of tin and lead. So they do have a low melting point compared to the lead and tin. And the electrical conductivity of alloys is always lower than constant metal. So as we know, copper is a good conductor. So copper is used in brass and bronze. Coming to alloy formation, so summation to that, it enhances the desirable property of a material such as hardness, tensile strength, and resistant to corrosion. Coming to different alloys, its composition and its uses. Brass. It's a mixture of copper and zinc. It's used in making utensils. Bronze. Copper and tin, making coins, bells, and utensils. German silver. Copper, zinc, and nickel in making utensils. Rolled gold. So copper and aluminium. It is used to make cheap ornaments. Gun metal. Copper, tin, zinc, lead. It's used to make the guns, barrels, gears, and bearings. Duralumin. Aluminium, copper, magnesium, manganese. So this is used in aircraft construction, so aircraft bodies. Magnesium, aluminium, and magnesium. So it is used to make the metal mirrors and scientific instruments. Solder, so lead as well as tin used for soldering. Stainless steel, iron, chromium, nickel, carbon. So it's for making utensils and surgical cutlery. Nickel steel, so iron and nickel. It's for using to make electrical wires, automobile parts. Coming to steel, so steel they do have iron and some percentage of carbon that is used for construction. Alloy of gold. Pure gold is said to be 24 carats. So gold is alloyed with a small amount of silver or copper to make it hard. Thank you, students.